Hi guys, so far we figured out how to find the identity for sine, the double angles, and we did sine of 2 theta and the cosine of 2 theta. In this video I want to talk about the tangent of a double angle, and then in my next videos I'm going to start using these double angle properties to actually solve some problems, okay? So the tangent one, which is number 3, the tangent, we already covered the sine and the cosine in the previous videos. The tangent of 2 theta is given by this identity 2 tangent of theta divided by 1 minus tan square theta. That is the double angle identity for tangent of 2 theta. Guys, I would like to show you how we actually get this thing, okay? So to get it, we are going to start with the left hand side. It would make sense to start with the left hand side. So tangent of 2 theta, guys, if you have seen my previous videos, we can write tangent of 2 theta. You would know, like, we can write tangent of 2 theta as the tangent is the ratio of sine over cosine. So if tan theta is sine theta over cosine theta, then the tangent of 2 theta would obviously be sine of 2 theta divided by the cosine of 2 theta, right? As simple as that. Okay, this is again a basic property, and I have used this thing in my previous videos as well. When we had to evaluate the tangent of a tangent of a sum, then we used that. We broke it as sine over cosine, and then we went from there. Now, sine 2 theta and cosine 2 theta is something that we already know from my previous videos. Sine 2 theta is written as 2 sine theta and cosine theta. Okay, guys, you can go back to the formula sheet, or you can go back to my previous video where I talked about sine 2 theta and cosine 2 theta. And the cosine 2 theta we already know as well is cosine square theta minus sine square theta. Okay, so we started with the left hand side. We realized that tangent can be written as the ratio of the sine over cosine. We did that, and then we already knew what was sine and what is cosine, and we just wrote the formulas down for sine and cosine. Now, looking at this and then looking at what we want on the right hand side, we may feel like this does not still look like the right hand side. But guys, we can use some mathematical techniques to make it look like the right hand side. And we're allowed to use any mathematical techniques or any operations as long as they follow the mathematical rules and they were not like disobeying any mathematical principles. We can use any extra things that we like to make this look like that, because now we already know that we want to make this look like this. At least we have a reference point. So guys, what we can do here is, again, there might be more than one ways of doing it, so I'm going to do it one way. I have a ratio of 2, and I'm allowed mathematically to divide the numerator and denominator by the same quantity, because if I divide by the same quantity, I'm not going to change the ratios, right? So in this case, since I see there's a tangent here, right? There's a tangent here, and I know back in my mind, and we should all know back in our minds, that tangent is sine over cosine. So if somehow I'm able to get this as sine over cosine in the numerator, I should be able to get the tangent, right? So for that, what I'm going to do is I'm going to divide the numerator and denominator, and of course I have to divide by I can only divide by the common same number, same quantity in this case. I'm going to divide upstairs and downstairs by cosine square theta, and guys, you will see what will happen. So I divide, so I start writing this 2 sine theta cosine theta, and I'm dividing the numerator by cosine square theta, and then I have to divide the denominator by the same exact quantity as well. So let me first write the denominator, which is cosine square theta minus sine square theta, and I got to divide this whole thing by cosine square theta as well. Whatever we do to the numerator, we got to do the exact same thing to the denominator. So that's exactly what I did here. Now let's see what happens when we simplify this. Guys, one thing at a time. Let us just focus on the ratio upstairs. So this cosine and one of the cosines will cross out. So I will only be left with 2 sine theta over cosine theta. Please look at that carefully, guys. I did not do anything really crazy here. I just realized that there is cosine square here, which means it's cosine times cosine. So one of the cosines will cross away. This will go away with one of the cosines, and I'll be left with 2 sine theta over cosine theta. That is my numerator, right? And now let us focus on the denominator. In the denominator, guys, on the side, we can just, since I don't have too much space, so I'm going to probably break it down here. Guys, this cosine square and sine square theta, they both have to be divided by this. So can we break it like this? Cosine squared theta divided by cosine squared theta minus sine squared theta divided by cosine squared theta. I just broke it down into two pieces. I'm allowed to do it, right? Cosine squared theta divided by cosine squared theta. A quantity divided by itself is simply what? 1. So I'm going to write 1 here. Then I have sine squared theta. Okay, I'll write that out. Sine squared theta over cosine squared theta. Okay. Guys, we divided by a common quantity, cosine squared theta, upstairs and downstairs, and that comes with, again, that comes with practice, guys. That comes with practice. Like, how do I know I have to divide by cosine squared theta? Well, that comes with practice, but at the same time, since I know, like, I want to convert this into this form, so I know that tangent is sine over cosine. Somehow I have to get a sine over cosine here. So then I started thinking, how would I get a cosine? After thinking through different quantities, I figured out that if I divide by cosine squared, then one of the cosines will cross out. I'll be left with sine over cosine, and sine over cosine we know is tangent, okay? So guys, again, as I said, for me, since I have been like doing it forever, so it comes like, then it starts to come naturally to you. But that is the whole idea. Like, you have to think, you have to look at these expressions and think about it for some time, because I mean, these are basic identities. When one starts to actually verify and prove more complicated and advanced identities, then one has to, like, even if I go back like and look at these so many different types of examples, I mean, I cannot just come up with this cosine square, this quantity right away. I have to think as well. So guys, we all are basically on the same boat. We have to like look at these things, we have to think about them, and then we start doing our work, okay? And guys, don't be afraid. Like, sometimes even for me, like I start with a quantity, it does not work out, then I think about something else. Sometimes I have to think about like 4 different quantities before I get the right one. So guys, the idea in mathematics is like, try and try. I mean, don't be scared of your failures. Like, if you are not able to get something right away, okay, try again, try something different, So keep trying. That's the key thing. So let's now simplify this. So this is 2 sine over cosine, we know is tangent. That's good. So the numerator looks exactly like the numerator that we want here. Now let's see if the denominators are all the same. So yeah, actually there is a 1 here, that 1 here. And we know if sine over cosine is tangent, then sine squared over cosine squared is tangent square. Okay, so it is tangent square. Guys, this is what we have on the right hand side. So we were able to, in this video, we were able to verify that the tangent of a double angle, tangent of 2 theta is 2 tan theta divided by 1 minus tan square theta. Guys, I'm not saying that you have to remember the whole derivation. At the end of the day, again, you will have a formula sheet. You have to use the formula sheet to do other things, but it is always good to actually see the process, the things behind the scenes. So this kind of things behind this. This is what is happening basically behind the scenes. Again, guys, if you have watched my previous videos, I still like to start with the, whenever I'm doing something with the tangent of a double angle or tangent of a sum, I like to start with the ratio of sine over cosine, but sometimes it might be easier to work with this as well, depends on a particular problem. So you have to look at the problem and then decide which method you want to use, okay? So guys, this is sine, cosine, and tangent of the double angles. In my next videos, I'm going to be actually doing some examples using these identities. Okay.